Hi guys, we're going to look at the volume of pyramids and cones today. Try to come up with a formula for that. I actually want you to first consider a cone and a cylinder. Don't worry about writing any of this down yet. We'll write some things down on the next slide. Okay, so we have a cone and a cylinder. And they have some things in common here. They have the same height. So this comparison that we're going to do, this is an important piece of it. They've got the same height and the same base, same size base, so they have the same radius. Now, the first question is, how do you think their volumes compare? Which one could hold more stuff? I would assume we would all answer the cylinder. Okay, so the volume of the cylinder is greater than the volume of the cone. But by how much exactly? We know how to find the volume of a cylinder. Okay, we do area of the base times the height of the whole thing, or pi r squared times h. So if we can figure out how these two figures relate to one another, we'll use that to find the volume formula for a cone. Now, if we were in class, I'd have this fancy little demo for you involving, actually I use rice, usually just dried uncooked rice. And what I would be doing, so imagine this is happening in class, I would take that cone, fill it up to the tippy top with rice, and then we would do a quick kind of guess. How much bigger do you think the cylinder is? Or let me rephrase that. How many cones worth of rice can we fit in the cylinder? Okay, maybe you think, 2 cones would fill up that cylinder, 3 cones, 4 cones, just eyeballing it and thinking about it that way initially. It turns out that if you take that cone full of rice and dump it into the cylinder, it takes exactly 3 cones to fill that cylinder up. Okay, so what I'd like you to do, and I do want you to draw with me in your notes, just as a little reminder, because if you can remember this visual, you basically have the formula already. So go ahead and draw just 3 little cones. 1, 2, don't make them too fancy. 3, try to make them congruent-ish. And then those equal the cylinder. Let's go for same base and height as that cone. So if I took 1, 2, 3 of them, I could fill up that cylinder. Okay, so let's write a couple things down here. We're going to say the volume of 3 cones equals the volume of 1 cylinder. Again, let's make a note here. Same base and height. Okay, now what we care about though, I don't want 3 cones every time. We really just want 1 cone. So if you think about what one of those cones would look like, how much of the cylinder would it fill up? Can you answer that question for yourself? If I took 1 cone and filled the cylinder, how full would the cylinder be? It would be 1/3 of the way full. So the volume of 1 cone equals the volume of 1/3 of a cylinder. So if I know how to find the cylinder's volume, which we do, is just area of the base, pi r squared times the height, I just divide it by 3 or multiply by 1/3 to find the volume of the cone. Okay, that same concept applies to pyramids as well. So if you had a pyramid and a prism, let's say you had a trapezoidal pyramid and the same trapezoid for a trapezoidal prism, it would take 3 of those pyramids to fill up the prism. Okay, so for both of these, let's write down real big here. Here's our volume formula. So this is volume of either a pyramid or cone. Capital V for volume equals 1/3 times capital B for area of the base, capital H for the height of the whole thing. Now, just like in this last section, capital B, this is base area. You need to insert an area formula. Based on the shape of the base. Okay, remember, hopefully you've gotten used to the height, finding that's we sort of are rephrasing this, especially if the thing is turned on its side. This is how far apart the bases are from one another. How far apart the... Oh, well, let me back up here now. As I'm writing this, I'm rethinking. So that's what it was for a prism or a cylinder. We should talk about this piece. There's only one base in a pyramid or cone. So we'll just make sure that we have the perpendicular height. This is from the base to the vertex. Sorry about that. I was still in prism cylinder mode here. So this is the perpendicular distance from the base. There's only one of them this time. It'll be much easier to spot, to the vertex, the very tippy top of either the cone or the pyramid. Okay, you should have come across that term in the very first section that you read in the book. Okay, so this is really the only change from what you did in lesson 10.2. Okay, we just need to multiply by a third or divide by 3. You decide which way you like to do that better. Okay, so you're going to hear me say a bunch of times, if it comes to a point, so that's my way of saying if it's got this pointy vertex at the top, or not necessarily at the top, of course, but if it's a pyramid or a cone, make sure you multiply by a third. Let's just try some practice problems together. If you would like to sketch these out, go for it. If not, I don't have the page written down. It's from 10.3 in your book. I apologize. I don't have the page number in front of me. Okay, so the first thing, we've got a square pyramid. I'm going to write this down, at least for the first few until we get used to it, because it comes to a point, right? Here's the tippy top, the vertex. We're going to use a third. So area of the base, 1/3 times the area of the base times the height. So we're still doing the same thing. It might not be a bad idea still to kind of outline that base. It should be a little bit easier to find in a pyramid or a cone. But I still want you to be thinking about, okay, that's a whole area formula, not just 8. Can't tell you how many people I see just put 8 in for capital B. Okay, so volume is equal to 1/3 times, I'm going to go all the way through here, base times height, since that's a square, times then capital H height, and that's a little easier to find this time, right? Just 9. Okay. Hopefully you did this already. If you need to stop and you want to pause and kind of sketch these diagrams, go for it. All right. I'll try to make a note. I know the video's already halfway through, but I'll try to make a note when I post this on the Google Classroom what page these problems are coming from. If you want to just look at your book as well, you can do that. Okay, so back to this. Volume equals 1/3 times 8 times 8 times the height of the whole thing. Okay, please do not use 0.3 for a third, or even 0.33 for a third. It's just not close enough. There should be no rounding error in here. So if you're typing this in the calculator, you can just do 1 divided by 3 times 8 times 8 times 9. You can also do 8 times 8 times 9, get a number, and then divide that whole thing by 3. That would be fine as well. You decide which way you prefer to do it. This one should actually be exactly 192 cubic centimeters. Did it say at the top? All measurements are in centimeters. It's nice to have a unit there. Okay. Okay, number 2, nothing crazy about this one. Our base is just a circle. Here's our capital H height. Notice it has a perpendicular marking. Let me back up here to number 1. We've seen this before in other examples, but see how they pull the height outside sometimes. You do need to be careful in a pyramid, well, in a cone, both of them. Remember, we have that thing called the slant height. So if they were to give you either this measurement right here, lying along kind of the middle of that triangle, or this edge right here, we don't care about either of those. This is the time we actually want the height of the whole thing, the perpendicular height. So if you remember me doing this, I kind of put a pencil up through the middle of the pyramid or the cone. That's the one we actually want this time. Let me see if I can draw that in here. So this would go from here straight down, perpendicular. That's a weird dotted line. Sorry about that. Perpendicular to the base. Okay, so it's here in number 2. It could also be outside like that as well. All right, so sorry, we're getting a little sidetracked there. Back to number 2, we want 1/3. Now our area of the base this time is pi r squared times capital H height of the whole thing. If you're comfortable just going and plugging the numbers in for something like this, I think that's fine. Okay, so 1/3 times pi times 6 squared. You could just put 36 there if you want. The height of the whole thing is 7. If you would like to have it as an exact value, great. That's 84 pi cubic centimeters. If you prefer the decimal, that's okay with me too. It's about 263.9 cubic centimeters. Okay, next one. Trapezoidal pyramid. You've got to get used to right off the bat. I see a pyramid. Okay, I'm putting a third. Capital B comes out. The base is a trapezoid, so in goes the trapezoid area formula. 1/2 base 1 plus base 2 times height. And then remember, times the height of the whole thing. So when we're talking about our base, the area of that whole thing, 15 then is my capital H height. We will see some practice problems either today or tomorrow where they give us some heights that we don't necessarily want. Okay. As long as you're careful, kind of plugging everything in, should be okay with this one in the calculator as well. Base 1 and base 2 are 4 and 8. Those can be interchanged, that's fine. The height of the trapezoid, so 5 is little lowercase h, right? And then 15 is height of the whole thing. If you're careful in the calculator there, that whole thing is 150 cubic centimeters. Be really careful with the parentheses. Might not be a bad idea to get just an area for your trapezoid, make that one single number. I think it's 30. And then you could go from there. So you're not plugging so many parentheses in at once. Okay, next one. Now, this thing, believe it or not, is a pyramid. Right? So if you're thinking of this like, oh, that's a triangular prism, there are no two congruent parallel triangles across from each other anywhere. Okay, what we do have, and actually you can use any base, we just have to make sure we have the right information. We've got a base and then each vertex is kind of connected up to the top vertex. Now, in this example, technically any side could be the base, you just have to make sure you have the proper information to find its area. So what we're going to choose is actually the one on the bottom. So when we're talking about 1/2 base times height for this piece right here, we don't have that yet. But we know how to find this, so this would be like little h height of the triangle, where this is capital H height of the whole pyramid. Let's not get those mixed up. If you know your Pythagorean triples well, this is just 12, 5, 12, 13. If you don't, that's okay. Here's what we'd be doing. 5 squared plus h squared, little h squared, equals 13 squared. Oops, not cubed, squared. And solving for h, like we did in the Unit 9. Okay, so again, we get 12 for that. So now, comes to a point, use a third. 1/3 times 1/2 base times height, 1/2 times 5 times 12, times the height of the whole thing, which is 6. 60 cubic centimeters is what we're working with on this one. Okay, let's do just one or two more together. That's all we're actually going to do today. I don't have extra practice for you, so bear with me here. I want to get through a couple different types of examples. Okay, number 5, semicircular cone. So it still has those similar properties of a cone. We're basically just cutting in half. So option 1, either just find the whole cone and at the end divide by 2. That would be fine. Or what you could do, option 2, the shape of the base right off the bat, so our capital B would just get half of pi r squared. You can decide how you treat that. Either way is fine. And again, if you want to kind of try this, you can pause it, try it without me, come back and check the answers. That would be okay. All right, so it comes to a point, use a third. Now we just want 1/2 pi r squared. I'm going to put the radius in right away. Did you catch that the radius is 6, not 12? And then times 14, the height of the whole thing. That should be either exactly 84 pi, same answer we had earlier, or approximately 263.9 again, cubic centimeters. You're getting in the habit of putting cubic units on there, hopefully. This is just approximately equal to, I don't know what that little squiggle is doing there. Okay, let's do one more together. This one's a little more challenging. This one has a cylinder with a cone removed. We saw a lot of area problems where they would say, find the area of the shaded region. This is sort of that same thing. We just want the area of kind of what would be left behind. So imagine you had like a cylinder made of cement and you drilled out the cone portion of it and got rid of that. We just want what would be left. So let's think big picture first, right? We want volume of, if we started with the whole thing, that would be the volume of the cylinder minus the volume of the cone. Well, if we don't want it, we're going to subtract that out from our total. Now, the cylinder is just area of the base times the height. So our base, in either case, is that circle, whether we're talking about the cylinder or the cone. So we've got, I'm going to just put the whole cylinder in parentheses here, pi r squared times the height of the whole thing, 16, minus a third of pi r squared times 16. Now, if you're comfortable with this idea, notice these are the same. We basically have the whole thing minus a third of that. We're really left with 2/3 of the cylinder. If you are comfortable just finding 2/3 of the cylinder, go for it. That's a much easier calculation. Conceptually, it's a little bit harder. Okay, so the volume of the whole cylinder, I'm going to leave it in terms of pi first. Get a nice, neat, exact answer. That's 576 pi minus a third of that is 192 pi. That's exactly 384 pi cubic centimeters, or approximately, this answer's fine, 1,206.4 cubic centimeters. If you were to just find 2/3 of the cylinder, that's what you would end up with as well. Okay, that's it for today. Please let me know if you have questions. Tomorrow we'll do some practice, and we're going to try to submit on that Google Classroom, or the Google form one more time. Hopefully that works a little better tomorrow. Okay, have a great night.